This is Algebra 2 with Trig, Unit 6A.2. We're going to model exponential growth and decay functions. We're looking at exponential growth model. That's going to be y equals a, b to the x. And that's when our b value is greater than 1. That would be exponential growth. In the last 12 years, the initial population of 38 buffalo in a state park grew by 7%. We're going to write an exponential growth model. So we could say that y equals a times b to the x. A is our starting point. Okay, that's our starting point. B is our common ratio. So our starting point is 38 buffalo. We could actually use an n in this location because it talks about the number of buffalo will be. All right, so that's going to be our n, actually. We have 38. We are increasing by 7%, so that's going to be 1 plus 0.07 to the t, the number of years. So our best equation would be combining those at 1.07 t. That would be exponential growth because we're adding, we have a value greater than 1, our initial amount, and for how many years we'll be calculating this, t years. So they want to ask, how many buffalo are we going to have after 7 years? Well, if we take our n equals 38, 1.07 to the 7th power, because that's the number of years, we can calculate out how many buffalo we'd have. So we have 38 to the 1.07 to the 7th power. And it's going to come out to be 61.02. If you wanted to give that a value of 61.02, but we can't have partial buffalo, so maybe our best answer would say about 61 buffalo. But by showing the 61.02, that's showing you did your calculations pretty accurately. And this would be our effect of rounding to have a real amount of buffalo. Now, using our graphing calculator, we can calculate when are we going to have 53. Some people think that you can put the 53 in place of the n and then solve your equation for t. And that's totally possible if we knew how to solve for an exponent. But we don't know how. You can divide by your 38, but how do you break up a base and an exponent? We'll learn about that soon. So another way to do it is to type it into y equals. We type our equation of 38, 1.07, into our graphing calculator to the exponent. We can't put a t in for our exponent, so we just put an x. So if we look at our table, you'll notice in the table that the number of buffalo is increasing, and we want to see where is it going to become 53. We can approximate that by looking here at our table, and it's going to be less than 5, but I don't know just how much less than 5. Is it 4.5? Probably a little bit closer to 5 than that because it's pretty close to the 53. But I don't know for certain. So if I go back to y equals, I can type in the 53 into my y equals with both equations, and I can attempt to graph it. We know that the window is going to need to change. I'm going to need to go up to a height that's over 53. So let's put in 60, let's put in 70, any number you want to have greater than that, so that we have a chance to see where both those lines are going to cross. So we have our exponential growth, and we have our horizontal line of 53. So we've talked about the intersection before by doing second trace or the calculate, and we do that going to number 5. That's where your intersection is located. We have 2 equations that we need to find. Our first equation is written up here, and we hit enter to accept that. Our second one is here at 53. We hit enter. Then it says guess. Guess is very important if that equation crossed the other one twice. But since it only crosses once, it doesn't really matter. We can just hit enter. Or you can scroll over to get closer. It doesn't matter. Hit enter. And you'll get to 4.91 or 4.92 if you round it to the nearest hundredth. About 4.92 years. Just to look back and explain what we have earlier, up here in our equation, this isn't the t for the years. This is 1 plus 0.07. We're adding the 1 and the 0.07 together to get 1.07. We have 100% plus we have the growth of our 7%. Next, we're going to talk about compound interest. This can get a little complicated. Compound interest typically happens when we're dealing with money. And we're investing money and we're making money off that investment. Our compound interest is going to be 1 plus R over N. We're going to have our interest rate that's going to be compounded multiple times. And we raise it to N times T. That would be our compound interest formula. So this is where P is going to be the initial investment. And R is going to be the interest rate. The number of compounds per year is what the N is. Number of compounds per year. So, in other words, we're going to get money multiple times a year. And that is our compound interest. So we'll talk about that as we do our calculations. And T, of course, is just the number of years. So we'll come down here to this first question, and we're going to save for our first car. We're going to deposit money into the bank. So if we're going to use our equation of A equals P, 1 plus R over N to the NT power, we're trying to figure out how much money we're going to have after investing $2,900. The bank is going to pay 3.5%, and we're going to look at how much money we have after 3 years. So 2,900, 1 plus. Now we need to take our interest rate and we need to write this as a decimal percentage. So that is 0.035. We don't put down just the 3.5 in there. We've got to write down it as a decimal. If you want to think about our formula, it's over 1, but when you have a denominator of 1, we don't need to represent that. And 1 times your years is irrelevant, so it's just your years. 2,900, 1.035. We can combine those together now to the third power. That's our A value. That's how much is in our account. So now we're going to type this into our calculator. So we have 2,900. We use our parenthesis 1.035 because we're taking our 3.5% and writing it as a decimal. And we're going to raise this to the third power. You're going to get this 3.5%. That's over 100%. So 1.30 or 1.035 to the third power times the 2,900 gives us 3215.28. Now, where we really get into this compound interest is what happens if the bank gives us money more often than just once a year. Over here, this is assuming that we get our 3.5% at the end of the year. And we get this interest of 3.5% thrown into our account all at the end of the year. Compound interest means that we get it supplemented in at different times. They're going to give us a portion of our money every month. So what we'll be doing is taking our 3.5% and breaking that into 12 equal pieces. So we're going to take our formula of P equals 1 plus R over N, NT, A equals, we're depositing still $2,900, so we're going to deposit the same amount. We want 100% of that $2,900 plus extra. And we need an interest rate of that 3.5%, so we write our R as 0.035. We're dividing that up into equal amounts, and if we compound it monthly, that's going to happen 12 times throughout the year. We're going to get this amount 12 different times for a total of 3 years. So 12 times 3 is our exponent. So look at how we plugged our values into our formula. 2,900 for our initial investment. We have the 1 because we want 100% of that money plus our interest rate divided into 12 pieces, paid over 12 months for 3 total years. So what is 3%? 3.5% really. 0.035 what is that when it's divided by 12? That means that we're going to get 0.0029, 1.0029 for 36 calculations, for 36 months, because it's over 3 years. 3 years is 36 months. And we can type that all into our calculator. 2,900, 1.0029 raised to the 36. Now notice how this number of 3,218 is different from our answer of 3,215. We invested the same amount of money, 2,900. We had the same amount of interest rate, 3.5, written as a decimal. The difference was that in a compound interest of happening monthly, they put money in at the end of each month. So after the first month, we actually have more than $2,900 in there. And after the second month, we have even more than that. So when we take our 3.5%, it's doing it of even larger amounts. So that's why we slowly grow. Over 3 years, we don't see a big difference. But over a lifetime of an investment, like for a retirement, that could be very dramatic. So 3,218.64.